In this presentation, we will understand how to convert binary number to decimal number and vice versa. So without any further delay, let's get started. The first topic is Introduction to Numbers System. The second topic is Decimal to Binary Conversion. The third topic is Binary to Decimal Conversion. After discussing these topics, we will then see the homework problem of this presentation. So without any further delay, let's get started and let's see what is a number system first. So what is a number system? A number system is a system that represents a quantity through a set of numbers. So a number system is a system that represents a quantity. For example, I have $100 in my wallet. So currently in my wallet, I have $100. So I'm representing the money in my wallet by the number 100. So the quantity is represented through this number 100. So in this way, I can represent the money in my pocket by this number 100. The number system that is used here is decimal number system, where each digit of the number can lie in the range from 0 to 9. A number system is a system that represents a quantity through a set of numbers. I hope this is clear. Just like decimal number system, we have other number systems as well. And now I'm going to list down those number systems one by one. So let's see what are the different types of number systems we have. The first is decimal number system, which we are well familiar with. The base of decimal number system is 10, which means that each digit of the number can lie in the range from 0 to 9. So base 10 tells us the range of each digit of the number, which is 0 to 9. I hope this is clear. The second number system is binary number system, where base is 2, which means that each digit of a binary number can lie in the range from 0 to 1. Only two allowable digits, 0 and 1. The third number system is octal number system, where base is 8, which means that each digit of an octal number can lie in the range from 0 to 7. And the fourth number system is hexadecimal number system, where the base is 16, which means that each digit of an hexadecimal number can lie in the range from 0 to 9, then 10 to 15 are represented by the letters A, B, C, D, E and F. So these are all the number systems we have, and we have more number systems as well, but I'm not going to list down here. These are the basic number systems that we have. After seeing different types of number systems, we are now ready to understand how to convert decimal to binary and binary to decimal number. First, we will understand how to convert a decimal number to a binary number. So this is the next topic that we need to deal with, that is decimal to binary conversion.
Have you been encountering repeated numbers or numbers in a similar pattern quite often?
IT professionals are getting fired. Mass layoffs are happening. Hirings have been freezed and you're scared. Am I right? This is the situation of...
We are done with introduction to number system. We have understood what a number system is. Now let's see how to convert a decimal number to a binary number. Instead of going through a lot of theory, I will give you one example, and with the help of example, we will then try to understand how to convert a decimal number to a binary number. So let's consider one simple example. Here we need to convert this decimal number 25 to an equivalent binary number. Now let's try to understand why this is a decimal number. This is a decimal number because base here is 10. As I have already told you, the decimal number system has base 10 and binary number system has base 2. Base is usually written as a subscript of the number. So here this number has base 10, which means that this number is a decimal number. And now we need to convert this decimal number to its equivalent binary number, as the base given here is 2. In order to convert this decimal number to its equivalent binary number, we need to perform one procedure. For this, we need to first draw these lines. After this, we need to mention this 25, this number over here. Now we need to divide this number by 2. For this, we will mention 2 here. So 2 must be written here and 25 must be written here. This means that divisor will come here and dividend will come here. Now we need to divide this number by 2. After dividing this number by 2, we will get the quotient and the remainder. If we divide 25 by 2, we will get 12 as the quotient and we will get 1 as a remainder. We must mention the quotient here and the remainder here. Now, after dividing this number 25, we need to divide this number 12, the quotient. Now, we need to divide this number again by 2. We will get 6 as the quotient and we will get 0 as the remainder. Now we need to divide this number 6 by 2. Again, we need to put 2 here, and as we divide this number by 2, we will get 3 as the quotient and 0 as the remainder. Then we need to divide this number 3 by 2. We will get 1 as the quotient and we will get 1 as the remainder. After this, we need to divide this number 1 by 2. We will get 0 as the quotient and we will get 1 as the remainder. Now we need to stop here. As soon as we get 0 as a quotient, we need to stop immediately. Now here we got a series of numbers. These are all remainders. Now we need to read these numbers from bottom to top. Here we are getting 11001. This number 11001 is the binary equivalent of this decimal number 25. You need to remember the numbers should be read from bottom to top. So here I have drawn the arrow so that you will never forget this. So now as we read these numbers from bottom to top, we will get 11001. So this is the binary equivalent of number 25. 11001. Now let's see one more example to concrete this concept. Here 90 is the decimal number and now we need to convert this decimal number to its equivalent binary number. We need to start with this number 90. We need to put this number over here. Then we need to put the divisor, which is 2, over here. Now we need to divide this number by 2. We will get 45 as a result, which is the quotient, and we will get 0 as the remainder. Now we need to divide 45 by 2. We will get 22 as the quotient and 1 as the remainder. Now we need to divide 22 by 2. We will get 11 as the quotient and 0 as the remainder. Now we need to divide 11 by 2. We will get 5 as the quotient and 1 as the remainder. In the same way, we will get the other numbers as well. You can check this on your own. As soon as we get 0 as a quotient, we need to stop immediately. Now we need to read these numbers from bottom to top. Here we will get 1011010. So the binary equivalent of this number 90 is 1011010. This is what I have written here. 90 base 10 is equivalent to 1011010 base 2. I hope this is clear. Now we have completely understood how to convert a decimal number to its equivalent binary number. Now we need to head to the next topic, that is binary to decimal conversion. Let's understand how to convert a binary number to its equivalent decimal number. Let's see how to do this. In order to understand how to convert a binary number to a decimal number, we first need to understand how a decimal number is represented. Let's say that we want to represent 625. This number is a decimal number. If we want to get this decimal number, first we need to place its digits like this. 6 to 5 are placed like this. Now, in order to get this number 625 from these digits 6, 2 and 5, we need to multiply each digit by its positional weight. Now, what is the meaning of positional weight? We first need to see the position of each digit in order to know the positional weight of each digit. The position of this digit is 0. Position of 2 is 1. Position of 6 is 2. We should read from right to left and we need to start from 0. Now we know the positions of each digit. We can now easily calculate the positional weight of each digit. For a decimal number, the positional weight is always of the form 10 to the power n, where n represents the position of a specific digit. So here, positional weight of this digit 5 is 10 to the power 0, because 0 is the position of this digit 5. Similarly, positional weight of this digit 2 is 10 to the power 1, because the position of this digit is 1. As the position of 6 is 2, the positional weight of this digit is 10 to the power 2. I hope this concept is clear. Now, as we know the positional weights of each digit, we need to multiply each digit by its positional weight. So we need to multiply 5 by 10 to the power 0, then we need to multiply 2 by 10 to the power 1, and then we need to multiply 6 by 10 to the power 2. Finally, we need to add them all. After addition, we will get 625 only. So this is the decimal number representation of this number 625. Here 6 is multiplied by 10 to the power 2, which means that 6 is multiplied by 100. So we will get 600. Here we will get 20 because 2 is multiplied by 10. Here we will get 5 because 5 is multiplied by 1. 10 to the power 0 is 1 only. So we will get 600 plus 20 plus 5, which is equal to 625, or in other words 625. So in this way we can obtain the decimal number 625. I hope the concept is clear. So
एक इम्पॉर्टेंट इन्फॉर्मेशन आपको देनी थी कि PW SAT होने वाला है, फिजिक्स वाला स्कॉलरशिप एडमिशन टेस्ट होने वाला है.
So, with this concept, we can easily convert a binary number to its equivalent decimal number. This is the reason why I have shown how to represent a decimal number. Now, in order to convert a binary number to its decimal number, we need to multiply each digit of that binary number by its positional weight. Let's see one example to understand this. We need to convert 1011010, this binary number, as the base here is 2, to its equivalent decimal number. In order to obtain the equivalent decimal number of this binary number, we need to multiply each digit of this number by positional weight. Positional weight of each digit of a binary number is of the form 2 to the power n, where n represents the position of a specific digit. Here the position of this digit 0 is 0. Position of this digit 1 is 1. Position of this digit 0 is 2. Position of this digit 1 is 3. So in this way we can obtain the position of each digit. Now we need to multiply each digit by its positional weight. So 0 must be multiplied by 2 to the power 0. 1 must be multiplied by 2 to the power 1. 0 must be multiplied by 2 to the power 2. 1 must be multiplied by 2 to the power 3, and so on. So, first we need to write this number, then we need to multiply each digit by its positional weight, and then we need to add all of them, just like what we did here. Here we will get 1 into 2 to the power 6, plus 1 into 2 to the power 4, plus 1 into 2 to the power 3, plus 1 into 2 to the power 1. Note that there is no need to mention 0 into 2 to the power 0, then 0 into 2 to the power 2. because 0 multiplied with anything will result in 0 only, and it will not contribute to this addition. Hence, we should not mention them. Here, we will get 64 plus 16 plus 8 plus 2, which is equal to 90. So this is the equivalent decimal number of this binary number 1011010. I hope the concept is completely clear. So this is how we can convert any binary number to its decimal equivalent. So I hope the concept is completely clear. This means we are done with this topic as well, that is binary to decimal conversion. As we have understood all these topics, we now need to see the homework problem of this presentation. Convert the following. So your job is to convert 158, which is given in decimal, to its binary equivalent. And then you need to convert 110011, which is a binary number, to its decimal equivalent. After obtaining the equivalent numbers,